All right, so today we're going to build a pyramid that includes the formula and description for each vocabulary word. So, how do you find acceleration? Okay, how do you find speed? And how do you find velocity? Okay, so for instance, for speed, what is speed? How do you find speed? Would it be distance and time? You would take and you would put it here. And then you would look over here and decide which one would go next. Change in distance over a specific amount of time, speed in a given direction, or change in speed or velocity over a specific amount of time. Let's just say that it's this. That doesn't mean that these are the right answers. It's just an example. But you're going to build yourself a triangle with all the appropriate parts that go under acceleration, speed, and velocity. Right here, you're going to tell me what is speed, what is acceleration, how can you calculate speed, and what does acceleration look like on a distance time graph. So you're going to drag the boxes over to the appropriate places for the appropriate answers. On this slide, you're going to read the description to the left and then choose the word that best matches that description. 64 miles per hour, would that be speed, velocity, or acceleration? Let's just say that you said that it was speed. You're going to take your answer and move it off to your left. If you get a green check mark, you are right. If you have a red X, then you need to put it back and you need to find the right answer. When you're done, I should see check marks all the way down this list. Right here, you're going to drag the proper answer to the question. What is work? An object being moved, a force causing an object to be moved over a distance, or pushing on an object. Same here. What two things do we need to calculate for work? Force and energy, distance and energy, or force and distance? You will need to complete this one as well. And it says, what is the formula for work? Is it work equals force times distance? Work equals force divided by distance? Or work equals newtons times meters? And we're going to watch a video on work here in a moment so that you can answer these questions. Okay, so here's our video right here, and we will watch and listen to what work is so that you can answer these three questions.
What does work mean to you? Doing chores around the house, sitting at a computer and studying for an exam, or writing a paper? There's a lot of work going on. So what does that have to do with physics? Well, in physics, work has a more specific meaning, and it does include some of the things I just mentioned, and a lot more. In physics, work happens when a force causes an object to move or be displaced. An object must accelerate for work to be done. If it doesn't move, or if it moves at a constant speed, no work is done. Work also relates to the amount of force we apply on an object, like when we're mowing the lawn or hitting a tennis ball. To figure out how much work, you need to know the force that's moving the object, F, and the distance the object moves, its displacement, D. The relationship between these terms is force times displacement equals work, W. If it takes 15 newtons of force to move an object 4 meters, then 15 newtons times 4 meters equals 60 newton meters. The combination of newtons and meters is called a joule. Capital J stands for joule. So it's 60 joules of work. Because a joule combines newtons and meters to make a new unit, it's a derived unit. Work is a scalar quantity. Even though it has no direction, it can be positive, negative, or zero. So if I apply a force in a certain direction, say I lift this box up, for example, I'm applying force upward, and the box is traveling upward too. This is positive work because force and displacement are in the same direction. If I just hold this box and don't move it, there's zero work going on. Work is negative when the force goes in one direction and the object moves in the opposite direction. So, if you're looking at the force of gravity and I drop this box, the work done by the gravitational force on the box is positive. It's moving in the direction of the force, down. If I lift this box up, the work done by the gravitational force on the box is negative. Its displacement is in the opposite direction to gravity. And there's no work done when the force and movement are perpendicular to each other. If I pick up the box, I'm doing positive work. And then when I walk, I'm doing zero work on the box since I'm pushing it upward, but it's moving to the side. When I set the box down, I'm doing negative work because my applied force is up, but the box's displacement is down. So here's another question. When I pick up the box, is work done in the X or Y direction? It's a vertical movement, so the work is in the Y direction. If I push the box across the desk, where's the work being done? X or Y axis? The direction of the motion of the box is horizontal, so the work is done on the X axis. So now that we know what work is in physics, think of all the work there is. A dancer being lifted up by another dancer, work. A weightlifter picking up a weight, that's work too. Where is the work when someone sits at a computer? Just sitting there isn't work. It is work if you're typing, putting force on the keys. You might argue that the body is burning energy, and that's work. You're correct, but that's a separate system, a chemical energy system. What we're addressing here is mechanical energy. So force and movement in the same direction is 100% positive work. Let's say the football player on the left is carrying the ball to the right, and he runs into the defender on the right. The defender will slow down the motion of the carrier. The ball carrier is slowing down and losing energy due to the force exerted on him by the defender. And the total amount of work done on the ball carrier is negative because he is losing energy. That's exactly how friction works. In physics, the work of friction is exactly the work of the defender. Friction is slowing the forward motion of the ball carrier, so the work done by friction is negative. How much work is done when you do a sit-up? Because you are lifting up, that's positive work, and then going back down, that's negative work. So the total work done is zero because the total displacement from the starting and end point is zero. Okay, here's another one. 5 football players push a 300.0 kilogram tackle sled across the field. The sled is accelerating at 0.25 meters per second squared. With negligible friction, what is the work done on the sled by the football players over 15.0 meters of pushing? To solve this, draw a free body diagram. Figure out all of the forces acting on the sled. Add arrows to see if any of the forces have the same or opposite directions. There's gravity pulling it down and the normal force acting up. In the horizontal direction, the players are applying a force to the sled, causing it to accelerate. To find the force of the football players, the formula is force, F, equals mass times acceleration. We can combine the force and work equations. Substitute the ma for F in the work equation and see that work is equal to mass times acceleration times displacement, or MAD. So that's the applied work, W sub APP, or the work exerted on the sled by the football players. Remember, the mass of the sled is exactly 300 kilograms, and the acceleration, A, is 0.25 meters per second squared. And the distance that the players are moving the sled is 15.0 meters. So it's 300 times 0.25 times 15.0, which equals 1,125 joules. Using significant figures, the answer is 1.13 times 10 to the third power joules. What about work done by gravity and the normal force? Remember, because they're perpendicular to the motion, they do no work. Now let's add energy to the mix. You know, there are all kinds of energy. There's electrical, solar, wind, and hydro energy. Without energy, there would be no work. Work transfers energy from one object to another. So think of energy as the ability to do work. According to the law of conservation of energy, energy is never created nor destroyed. It just gets transferred or transformed from one form to another. And there are a lot of different types of energy. Energy, like work, is a scalar quantity. It can have a negative or positive value, depending if it's added or removed from a system. But what is a system? A system is simply a collection of objects in a particular area that you want to study. Let's say it's the human body. Energy goes into the body, like food, which is chemical energy. And energy leaves the body, like in the form of heat. That's thermal energy. Let's put a box around the system. In this case, let's make it the human body. If the system is isolated from the outside world, it's called a closed system. If our system interacts with the world outside this box, it's called an open system. In this course, assume that a system is closed unless stated otherwise. So remember, a system depends on what you want to study. Your entire body could be considered a system. The Earth itself or the entire galaxy could be a single system. So let's summarize what we learned with this ball as the system. If I throw the ball in the air and catch it, we know that gravity does negative work as the ball rises and positive work when it falls. And the net work done on the ball by gravity is zero. There are all types of energy that we'll explore in other segments. That's it for this segment of Physics in Motion. We'll see you next time.
All right, so that is what work is. And we're going to get back to our slides here. Now that you understand what work is, you're going to answer the questions that are 4 through 6. And then right here, you're going to build a pyramid that includes the formula and the description for each vocabulary word. So you have the acceleration, speed, and velocity. So you need to determine which one of these is going to be acceleration, which one of these is going to be speed, and which one of these is going to be velocity. So you have 2.24 joules, 3.38.25 joules, 2,250 joules, 22,500 joules, 2,200 newtons, and then 1,375,000 newtons. And then whatever code you get, you will type it right here. So the specific code that you have right here, when you move this over, you should put in order under here, and it makes a code, and you'll type that secret code right there. And that is all for today.